So as continued from the earlier content, some relationships are not linear, but are curvilinear. And let's look at an example of a relationship that might be curvilinear. So let's draw the scatter plot as we normally do. And let's put on the x-axis arousal. And by this we mean sort of the extent to which you're feeling keyed up. So let's put being awake, alert, ready. And we might imagine that this goes on a continuum. I don't know if it goes to infinity or not, perhaps. Of feeling really low, let's say slow, lethargic. Sort of that feeling when you just wake up out of a deep sleep. And it might go up to a 10 where you're feeling really too keyed up. You know, maybe you're feeling like you just drank 10 cups of coffee. I'll just write that here. And then in the middle here where you're feeling, alert, ready, nothing too extreme. Okay, and let's imagine there are areas in the middle there. So that's arousal, and we're going to put it on a scale from 0 to 10, with 10 being that hyper coffeed up state. I'll put a little lightning bolt here. And 1 being a really drowsy, somnolent state. You can't even hardly see straight, so I'll put a little blue there representing sleep. And our level in the middle being right about, you're just average. And we'll put 2.5 in here. And now let's imagine that over on this y-axis, we have performance. And let's imagine it could be performance on maybe on an oral exam or a test you have to do or a presentation. Something like that. So how are you going to do? And so you could perform perfectly, or you could just blow it really badly, or somewhere in the middle. So what we find when we measure these out is that people who are really drowsy have a low level of performance. So here's a person who is really drowsy and they had kind of a poor performance. Here's another one, kind of drowsy, didn't perform very well. There's another one, kind of drowsy, didn't perform very well. And we also find that as people are really hyper keyed up, they don't perform that well either. Maybe they talk too fast. Maybe their ideas come too rapidly. They can't express themselves well. They become unaware of their audience. And so we find that people who are really keyed up don't do that well in their performance, and people who are too somnolent, too drowsy don't do that well. But if people are in the middle, they're active, they're alert, they're awake, they're feeling ready, prepared, that's when performance is optimal. And so we might have a relationship in which a straight line, I don't think you could draw a straight line through there that would accurately represent these points. Instead, you would need to draw a curved line. And this represents the curvilinear relationship. And we cannot represent this relationship using our Pearson R value. So I'll cross that off. We have to use a different test. It's called Spearman's rho. And that is the way that we would need to represent this. And we're not going to go into how that is calculated right now, but the concept is similar and the result is similar. So that's an example of a curvilinear relationship. So we've looked at perfect relationships right here, every point on the line. We've looked at kind of a moderate relationship. How do we decide what relationships are moderate and what relationships are strong and what relationships are weak? Well, in the social sciences, we have some thresholds that we can utilize to refer to. And these thresholds are cut at these values. So if R equals 0.2, we would consider this a weak relationship. We're not going to have a value of exactly 0.2. So approximately or thereabouts. If R equals 0.5 in the social sciences, we consider this a moderate relationship. And if R equals 0.8, we consider this a strong relationship, and the researcher is usually pretty happy. So these are the thresholds that we use, and I'm going to give you some visual depictions of what these might look like before we go into a little activity that will relate to your content for this section. So some more images of what strong, moderate, and weak relationships might look like, depending a little bit on the number in the sample. So here's our first scatter plot, and I'm going to draw a relationship that looks like this. And we might consider this to be first off, we would have a downward line of best fit, which means that it's a negative or inverse relationship. And so we'll write R equals negative. And the points are quite far from the line. And I would say this is maybe a negative point, maybe 1, 5 or something like that. And this would be a weak negative. A weak positive might look something like this. The points are scattered in an upward direction. The pattern is generally, you can tell the direction of the points. There is a sort of an organization there. Whoops. And it goes in a positive direction. That one's not quite in the center. And so maybe this is R equals 0.2, approximately. We call this a weak positive. If we have something that looks kind of like this, we'll draw smaller points here so it doesn't take as long. We can see that this cluster of points is a little bit tighter than what's above it, and still the arrow goes in a downward direction. And so this is a moderate negative. Something in the approximately, R is approximately 0.5. And we could draw this, and we can see how the points would be just similar, except going in an upward direction. And this is probably a little stronger than moderate. Let me put a few more points out here, maybe. And we would call this a moderate positive with R approximately 0.5. And finally, strong relationships. We can have something like this, where the points are quite close to the line. We have a nice tight cluster here. And we would call this a negative strong relationship, or a strong negative. Or we could see something like this, again with the points quite close to the line but going in a positive direction. Guess we're reversing our colors here. So here we have again, a cluster that maybe looks something like this. And we would say this is a strong positive. And this is an R value approximately 0.8. And this is R approximately negative 0.8. Both of these equally strong. The only thing that's different is the direction. You already know that we can have perfect positive relationships and perfect negative relationships. So if every point is exactly on the line, that is a perfect relationship, in this case a perfect negative. R equals -1, or a perfect positive. Every point on the line. And in this case, we would have R equals 1. And if we just have a mishmash of points with no discernible pattern, it would be hard to even figure out what direction the arrow is going. We'd be kind of guessing something like this. You know, we might say, okay, I think that would be positive, but it would be hard to say. And this correlation coefficient R would probably be close to 0. So it could be, you know, 0.1, or it could be 0.08, something like that, or it could be minus 0.05. All of those would be considered 0 correlations. And now to practice what we've just been doing, we're going to play a little game called Guess the Correlation. And it's right here, and you'll be doing this on your own for your think activity. It's really sort of fun. And so we're going to choose a number of data points. Now the number of points matters. The fewer the points you have, the lower the R value is likely to be, and you usually need at least 30 to get a good R value. So let's type in our 50 here. Let's take 50 in our data. And we're going to go ahead and track our performance. And let's go and generate a new sample by clicking New Sample. And so now we can see a cluster of data points, and our job is to guess the correlation. So first off, I'd say this is a negative correlation. And if I was to estimate the distance of all these points from the line of best fit, I would say they're pretty far. I'd say this is in the weak range of a correlation. I'm going to guess minus 0.18 and enter. And then it will tell us the actual answer. And it was much stronger than I guessed. So this was actually minus 0.426, almost in the moderate range. So now that we have sort of a baseline, let's go again. Click New Sample. Okay, this one looks a lot tighter. First off, I can see that it's positive, but I don't need to write that sign. So I'll just start by writing the point. And I'd say this maybe is in the strong range. I'd say this is like a 0.75. Let's see if I'm any closer. Let's check guess. And closer, but not that much closer. This time I was too high. So this is a 0.591. And if I scroll down, I can see that it plotted me. It plotted both of these points. So this is what I'm actually looking at. It's looking at how far off am I from the actual. So you can see it's tracking our performance. So I guess too high that time. So let's generate another sample. Oh boy, I'd say that looks pretty similar to the last one. The last one was 0.59. This one looks a little weaker. Let's guess 0.55. And this one was a little stronger. It's 0.620, but not too far off. We're getting a little closer. See, our guess here is closer to the line. Let's generate a new sample. Oh, what a mess. This looks like a 0 correlation. I can't even tell what direction it's going. I'll guess it's going positive. I won't put a negative sign. I'm going to say it's a 0.1. We'll see. And not too far off. It's 0.076. This last one is showing that we were actually pretty close on that one. The closer these are to the line, the better our guesses are. Let's get another sample. You're required to do 10 of these. Ooh, this looks pretty tight. I can see it's in a positive direction, so I won't put the negative sign. And I would guess this one at maybe 0.65. 0.65. Whoops, I have 2 points there, so it doesn't like that. So let's try again. And it's 0.583, so we're a little higher than it was. This is the one that I'm tracking with right now. And so we can see that we're a little further away from that line. We want to get our guesses really close. You're going to do 10 in total, as I said. So let's generate a new sample. Still positive, a little further from the line. I'm going to get this as just a flat out 0.5, moderate correlation. And we're pretty close, 0.472. There we go. Let's get another sample. Oh boy. We have this sort of flattened upper end, and I feel like that's going to it's going to distort this. You can see when in a later lecture, this is called range. Seems like it might have some range restriction. I'm not sure. But let's guess this correlation to be 0.6. And oh, much worse at 0.35. We really blew our record there. See that point so far away? That's okay. Let's go on and get another one. Okay, we have a negative here. I'm going to put that sign in so I don't forget. And I'm guessing this to be in the 0.4 range. I'll put 0.42. 0.251. Well, I got the minus right, so we got kind of far away from the line on that one too. Let's try another one. Ooh, a nice tight one. That is definitely negative, and I'm going to say it's 0.95. They're almost all on that line. 0.98, negative 0.98. We got really close on that one. We're almost on the line. All right, let's guess another one. Ooh, a positive one, kind of a messy cluster. I'll say 0.45. 0.35. I should have guessed. All right, and let's do one more. And this is going in the positive direction, and I'd say it's in the 0.6 range. 0.741. So my record didn't much improve over time, but we're in the ballpark. So that's what I would do now then, if I was a student, and what you're required to do is to look at our correlation. Now our correlation is pretty strong. There's a 0.97, so a strong relationship between our guesses and what was actual. And so that's not too bad. So I'm going to go ahead and take a screenshot of this using what in Microsoft is called a snipping tool. And I'm going to capture all of that, not that. Let me get that again. Here's my snipping tool. I'll get a new one if I can get my snipping tool to work properly. There we go. When it turns gray like that, it's going to allow you to capture, and I'm going to capture all of this. And you are going to be saving this and pasting it into one of your test items. So that ends our content on measuring correlations. To summarize, I would say that you should remember that, first of all, correlations are measured on a scatter plot. So I'll write down the key points that I think you should definitely remember. It's measured on the scatter plot. The statistic that we use is called a Pearson R-value. And the Pearson R-value measures two dimensions. It measures direction, positive or negative, and it measures strength. And it's 0 up to 1. And I think And we can also have, these are for linear relationships. So I'll write linear here. Let me cross that off and write that properly. Linear. But we can also have curvilinear relationships that cannot be captured by a straight line. And these would use a different statistic called Spearman's rho. So I hope you find this helpful. I think it's easier to learn it this way than looking at it through slides. And please ask me if you have any questions at all.